When you have a power cut, your torch has got to work. With this one, there's no fumbling around in the dark to find it because it actually glows in the dark. But the torch will only stay on after you find it if it's built to stay alight through just about anything. These millions of tiny pellets of industrial-grade plastic are the key to the torch's durability. They are on their way through a hopper to be turned into the torch's strong protective shell. This is the same heavy-duty plastic that's used to make things like hard hats, golf club heads and car parts. Yellow pellets are added to the mix to give the torch its eye-catching colour. A rotating barrel churns the pellets as they're heated to just over 200 degrees. The heat leaves the plastic soft enough to be squeezed out of the barrel like it was strangely coloured toothpaste. That's so the plastic can be shot into this huge 1,100 kilo mould that will form all the parts needed to make 4 torches. Why such a huge mould for just 4 torches? It needs to hold all the hoses for the injection system that pumps it full of plastic. Once in the mould, the plastic cools instantly and ejector pins pop out the torch parts. Another injection moulding machine makes the lenses that screw onto the torch body to cover the bulb. The lenses must be crystal clear so light can shine through. So they're made from polycarbonate, the same plastic used for glasses. Yet another machine moulds the glow-in-the-dark screw cap that holds the lens to the body of the torch. The screw caps are made from a special kind of plastic that naturally glows because it contains phosphorus. Phosphorus is an element that absorbs and stores energy when exposed to light, and then uses that stored energy to glow in the dark. To turn the glowing plastic pellets into caps, a worker places 4 lenses on the pegs in the press. And the press molds the glow-in-the-dark plastic directly around them. Then the lenses and the other moulded parts are ready for assembly. First, a worker adds a pressure valve to the body of the torch. The valve is needed because these torches are so air and watertight, gases from the batteries could build up inside. If that gas can't escape, there's a chance the torch could explode. A worker wraps an O-ring around the rim of the torch body. This blocks dust from getting inside and also makes the torch air and watertight once the lens is screwed on. A machine stamps in the battery contacts and a cord is tied to the end for easy carrying. And finally, the on switch is attached to the side. The switch activates the special LED bulb. This bulb emits white light that's 3 times as bright as an incandescent bulb and lasts 8 times longer. Once the LED bulb is in place, the lens cap and the lens screw on to complete the torch. And to be sure these torches are sufficiently rugged, prototypes undergo regular, rigorous testing. To check that they're both airtight and watertight, they are dunked in a bucket of water that's pressurized. The torches have to keep working underwater for 30 minutes in order to pass. Then there's the drop test. From a height of 2 meters. If the torch still works, it's ready to light the way, no matter how dark things appear.